All right, this is trig substitution with x equals a tangent theta, and so we have a different form of our radical now. Now it's a plus, and so we're going to be using 1 plus tangent squared. So if we convert this t squared to a 4 tangent squared, it'll help us make a secant squared. So our a here again is 2, because a squared is 4. So we're going to use t equals 2 tangent theta. And then that way, when we plug it in, it'll work out perfectly. So dt is 2 secant squared theta d theta. Now if we plug everything in, we get 2 secant squared theta. I'm going to put the d theta on the outside. And then inside we have 4 plus 4 tangent squared theta. So same thing we did before. We're going to factor that 4 out. So we end up with 2 secant squared theta, square root of 4, square root of 1 plus tangent squared theta. And so now you can see that 1 plus tangent squared theta would be secant squared theta. We take the square root, it turns into secant. So we end up with these two canceling. Let's get them out of the way. Secant squared theta over secant theta d theta. And then obviously those cancel again. So we have secant theta d theta. And we know that integral to be the natural log of secant theta plus tangent theta plus c. Now we go back up and we go tangent theta, just like before, is t over 2. We draw our theta triangle, and so that's t over 2. And then this is c. So again, c squared would be 2 squared plus t squared. So c squared equals the square root of 4 plus t squared. See a nice little pattern here. So we have, I'm going to erase it now and put square root of 4 plus t squared. So that means we already have the tangent. Tangent's t over 2. So secant theta would be the reciprocal of cosine. So that would be 2 over this. So we want that over 2. Hypotenuse over adjacent for our secant. All right, now we just have to plug it in. So natural log square root of 4 plus t squared over 2 plus t over 2. And there you go. Plus c. All right, let's try another one. So what if we don't have a radical? It still works the same way. You can see that our a here is 1 because the square root of 1. So the square root of 1 would have just been 1, so it doesn't change. So dx, let's write dt. dx equals secant squared theta d theta. And if we plug all that in, we get 3 secant squared theta d theta all over tangent squared theta plus 1 squared. So tangent squared theta plus 1, as we remember, is secant squared theta. So we're just going to replace that with secant squared theta. So we have 3 secant squared theta over secant squared theta squared d theta. Okay, so one of these is just going to cancel with that, leaving us with 3 over secant squared theta, because remember that's going to be 4, and 4 take away 2 is 2. All right. So now we just take this and rewrite it as cosine squared. So 3 cosine squared theta d theta, and then we can use our double angle identity. So this would be 3/2 integral 1 plus cosine of 2 theta d theta, and you should have your trig identity page that you can look these up, so if you don't forget them. So this is theta, 3/2 bracket, and then this would become plus sine 2 theta with a half in front plus c. All right, so now we have to go back and do what we did before, and I'm gonna just distribute that 3/2 right now. So 3/2 theta plus 3/4 sine 2 theta plus c, and then now we can go back and do our triangle. So tangent theta is just x. So that would make this x over 1. So this would be the square root of 1 plus x squared, or x squared plus 1. In fact, I like that one better, so I'm gonna rearrange it and put it back in. Square root of x squared plus 1. All right, so now sine of 2 theta is what we're looking for. And sine of 2 theta is equal to 2 sine theta cosine theta. So what we need is cosine and sine. So sine theta is x over the square root of x squared plus 1. Cosine theta is equal to 1 over the square root of x squared plus 1. So now if we plug that in, we end up with x over the square root of x squared plus 1 and 1 over the square root of x squared plus 1. So this ends up with 2x over x squared plus 1. That is our sine 2 theta. So now if we plug that in, we have 3/2, and theta is inverse tangent of x. So inverse tangent of x plus 3/4, and then sine 2 theta is 2x over x squared plus 1, which we can then use that 2 to cancel. So it's really 3/2 times x squared plus 1 plus c, and you can put a 3 on the top or 3/2 up there. There you go. So you can see these are pretty much the same, whether you have to plug in for tangent or sine, or even in the next one secant. They're all done the same. It's just which one do you choose, and that's just based on what you're given. So let's do another in the next video.